Welcome to the 11th part of SpringBoot with Kubernetes Tutorial Series. In this video, we are going to look at how to set up local development environment using Docker and DockerCompose. I would like to have a better developer experience where if any new team member joins the project, they should be able to simply clone the project and run a simple couple of commands and the project should be up and running. That is the kind of a developer experience I was looking for. In one of our previous videos, we have seen how we can Dockerize our Spring Boot backend application and how to create a container out of the Docker image and run it. But typically, our application has dependencies like database, cache servers, or things like that. So in that case, Docker Compose really helps a lot, where we can define all those dependent containers, and also we can configure our own application so that when you run Docker Compose up, it's going to spin up all those containers, required containers, and our own application, and it should be up and running within just a few minutes of time. Even better, I would like to go one step further, where instead of remembering all these Docker and Docker Compose commands, I would like to write a simple shell script where I should be able to check out the code and run this shell script with a start or stop, and behind the scenes it performs all those Docker Compose commands. So in this video, we are going to create these Docker and Docker Compose configuration files and create this shell script where it will help us to simply start the application and stop the application. So here in our project root folder, I have created a docker-compose.yaml file. So in this file, I have declared two services. One is bookmarker DB, another one is bookmarker API. So for this bookmarker DB, it's a logical name that I gave to the container, and I am specifying to create the container, use this Docker image. Here we are using Postgres 14 Alpine. And also I have provided some environment variable for username and password and the database name. And then I have declared these port mappings using this host port : container port. So by default, Postgres run on port 5432 within the container, and I am mapping it to the host 15432. So this way, once I spin up the container, I will be able to connect to it from my local laptop host machine using localhost 15432. Okay. Because Postgres is available as a public image, we can simply define image : and whatever the image we want to use. But for bookmarker API, this is our own application, and we want to build the image as and when we run Docker Compose up, which means we make some code changes and then spin up this container using Docker Compose, and we want to rebuild the image so that it picks up any changes and then spin up the container. Okay. So how do we say to build the image, right? So by default, there are a few options like here, I'm giving a logical name of bookmarker-API, and using this build, we can specify what is the root context and where is the Docker file. Here I'm specifying context as within this root directory, we have bookmarker-API, which is the context root directory. And by default, if you don't specify what is the Docker file, it is going to assume Docker file as the file to be used to create the Docker image. But here, if you remember in one of our previous videos, we have created two Docker files. One is with a single stage fat jar based Docker image, and another one is multi-stage based layered approach image. Okay, so here we are specifying use this dockerfile.layered file to create the Docker image, and consider bookmarker API folder as the context root. Okay. After that, if you notice, we specified a bunch of environment variables. If you take a look at this main application.properties file, right now we have not defined any database properties. By default, if you are not specifying any database, and if there is any in-memory database driver, it is going to automatically use embedded database, right? But if you have to point to any other database, you can use spring.data source dot driver class name, and similarly there are a bunch of other properties like what is the JDBC URL and username and password. Username and password. So like this you can specify whatever properties you want to provide for this database connection. And Spring Boot provides a facility where you can override any of these properties if defined, or you can also provide these values if not defined using this notation. So what it does, it takes this whole property name and replace dots with underscore and capitalize everything. So here spring.datasource.url, right? So we can override that value using caps spring underscore data source underscore URL. So we are providing the database connection to this container. So the driver class name is, we are going to use PostgreSQL. So we define the PostgreSQL driver class name. And what about the data source URL? Usually it is like a data source colon PostgreSQL colon / host name colon port number / database name, right? But here, when we are spinning up these two containers, by default they run in the same network, and whatever the name we give to this container act as a host name also. So from this container we are trying to talk to this PostgreSQL container. So the host name, instead of localhost, this bookmarker -db becomes the host name, and the port number still remains the port number within the container. This is the tricky part, like when we map this 15432 from host to 5432, you can connect from host machine using this port number. But when you are talking from one container to another, it's going to be like take the logical host name and use the actual container port, not the host port. Okay, and we specify what is the database name, and similarly we overridden this username and password, which are nothing but these values. Okay, and similarly our application is going to run on port 8080 within the container, and I am mapping it to 18080 on the host machine. And this we can specify if anything goes wrong, you want to restart always, or what to do. And also we can specify on what other containers this container depends on. So here our bookmarker API depends on the PostgreSQL containers. So here we define what is the dependency. Okay, so now we have this DockerCompose YAML file defined. So let us see how we can use this DockerCompose file and then run the application. Okay, so here I am at the root of the application directory, and here I am going to use DockerCompose up. So it is going to create these two containers. If this image is not already downloaded into your local machine, it's going to download first and then spin up a container. And here it's going to build the image right now using this docker file.laid definition here. Okay, so once we can remove this. Okay, yes, so here you can see it's been up both a database and our API, and we can see the application started successfully. And again, looking at Compose port mapping, now I should be able to access the API on localhost 18080. Okay, so here, yes, I'm getting the data. So I'm not accessing on port 8080. 8080 is container port, which is mapped to 18080 on the host, which means my laptop. Okay, so here I'm running the application and I'm able to access this. Cool. But here, if you see, if I press Ctrl C, it's going to stop the containers also. Now, if I access this, the application is stopped already. So what we need to do, we can do, if we want to run in a detached mode, you can pass -d flag, which is like it spin up the containers and run them in the background, and we can return to the terminal. You can run any other commands, right? So now again, if you go back and access this, it is running fine. Okay. But what about if I want to see the logs? Okay, the containers are running, but I want to see the logs. What we can do, we can use DockerCompose logs -f. So it is nothing but like a tail command. It's going to follow up the logs and then show as and when you access anything, it is going to display those logs. Okay. And one more thing is, by default, when you run any DockerCompose up or DockerCompose log, any commands, it's going to assume that there is a file with docker-compose.yaml file. But for any reason, if you name it as a different DockerCompose file, like docker-compose-app, something like that, you need to specify the file name like this. DockerCompose app.yaml. So like this, you can specify if it is different from docker-compose.yaml file. Okay. Nice. Now the application is running. What about if I want to stop it? Okay. There are two commands. One is, I can simply say DockerCompose stop. It's going to stop all the containers that are spin up from this DockerCompose definition. And if I want to remove all those containers also, I can specify rm. Yes. So it is going to delete the containers also. Earlier, they just stopped the containers. With this rm command, you can even delete the containers, which are created from this Docker definition. And one more crucial thing to remember is, when we specify this container for our application, and if you spin up the container using DockerCompose up -t, and then let's say you make some changes, and then you want to pick up those changes, and then you come to console and then run the command again, assuming that it might pick up the changes and create the container again. But it's not going to create the container again because the container is already built. So to force that recreation of the container, you can specify -- build argument. So in this case, you can see here it is going to again create the container. Okay. While the current DockerCompose setup is working fine, I would like to split it into two separate files. One for all our own applications and one for all the dependencies. Right now we have only one dependency, but usually there can be many, like database and Redis, Elasticsearch, things like that. Why? Because sometimes I want to spin up all the dependent services in Docker, and then I want to run the application from my IDE, because most of the times I frequently change the code and immediately I want to see the change in action. If we run our application also in Docker container, it's going to be a little bit slower process to spin up the container and then verify the behavior. So in that process, it is easier to spin up all the dependent services in Docker and run the application from IDE. So let us do one thing. Let us take this DockerCompose YAML and then create another one like app. Okay, so in app, I'll define only bookmarker API and I'm going to remove this. Okay, and I'm going to remove bookmarker API from this file. Okay, so now we have two files. Then if you want to run the entire application, both the dependent services and the application, how do we do that? As I said earlier, if we are going to use multiple files, what we can do, we can specify -f DockerCompose YAML and also specify -f DockerCompose app YAML file app -t. So if you have multiple files, you can specify each of those files using this -f flag and then run them. So it is going to take definitions from both the files and then run the application. Okay. Again, when you want to see the logs of both the containers from two different file definitions, you can do the same, like logs -f. You can see the logs. Here you can see logs from database and then API as well. Okay, cool. So now we have DockerCompose file definitions and we know how to run them. But the challenge is every time when you want to run it, you need to run these long commands where you might get wrong the syntax and all this one. So this is where I would like to simplify it using some kind of a shell script so that you don't have to type these long commands. So what we are going to do, we are going to create a shell script and create some functions which call some of these specific commands based on it. Okay. So here I have created this run.sh shell script, and I have declared two variables. One is pointing to the DockerCompose file, another one pointing to the DockerCompose app file. Okay. And here I have defined few functions to replicate typical set of commands that we would perform to do some action. So one is to have build API. So here what we are doing, we are seeding into this bookmarker API folder and then creating the SpringBoot jar file. And we have this start infra where we are using this DockerCompose command, and we are using only the infra YAML definition file up -d in detached mode, and immediately we are streaming the logs also. Okay, and stop infra where we are stopping all the containers infra from the infra file, and also we are immediately removing those containers as well. And here we have a start. From the start function, we are calling this build API because before picking up these changes, we need to rebuild the application. So that's why we are calling this function. And then we are specifying both the files, -f infra file, -f app file. And then we are running up and then building this one. This time, because it includes our own application, and to pick up the changes, we need to pass this build flag as well, and running in the detached mode. Similarly, as soon as you run it in detached mode, we are logging also. Okay, and stop, again we are stopping and then removing the containers. And as a convenient utility, we have this restart function where it stops and then immediately starts. Maybe if you want to put some sleep for 3 seconds, we can put it like this. And here I have a variable defined action which is assigned to start. And then here I am checking, is there any arguments that are passed to this shell script? If there is no argument, we are if there is arguments, we are assigning that argument to this action and then evaluating that. Essentially what it does, from the command line, if I simply call run.sh without passing any arguments, it is going to take this action equals to start and then evaluate that start function which is there right here. But if I want to do something else, like if I call run.sh space start infra, okay, so here it's going to check, okay, there is some argument, and then it is going to assign action equal to start infra, and here start infra function will be called. Okay, let us see it in action. So right now, and before running this, we need to add execution function, execution permissions to this script, and then you can simply call run.sh without giving any arguments. So what it is doing right now, it is going to take this start as the action, and when it is called eval start, it's going to run this function. So if you see the logs here, first it built the Docker jar file from the backend API and then spinning up the containers. So now it spin up both the backend API and database as well. So now here we can access the application. Fine. Similarly, we can call other functions. By default it is start. Now I can pass this stop function and it's going to be stopped and then removed as we defined in this stop function. First we stopped containers from both the files and then we removed them, this forceful flag for any reason. Okay, and If you want to spin up only infra components, start infra, you can call start infra, and here if you check the logs, it is starting only database, it's not starting application as well. Okay, so cool, we started all the infrastructure containers only. Now how do we run our application using that database which is running in Docker container, right? So if you take a look at this DockerCompose file, here the container, the Postgres database within the container is running on 5432, and it is mapped to 15432 on the host. Okay, now we should be able to connect to this database. Let us use data source and PostgreSQL, and here host is localhost and the port is 15432, and Postgres and database is appdb. Test the connection. Yes, it is. See, right now there are no tables created, but we are able to connect to the database. Okay, now as I said earlier, if we want to run our application pointing to the Postgres database which is running in Docker container, what we can do, we can create a application local profile property. Okay, what I will do, I'll create a file, application hyphen local.properties. Okay, and here I'm going to pass those database properties in this file. It's going to be string.datasource.driver class name. But we are connecting from our local host machine to the Docker container, so this doesn't resolve to any actual host name. We are going to use localhost and the port is 15432. Okay, and once we have this local profile definition, instead of running application with the default profile, what we can do, we can enable, if you are using IntelliJ Ultimate Edition, you directly have this active profiles option in your run configuration. You can specify local. Okay, and when you start the application with local profile, you can see in the log, so the following profiles is active, local, and it is going to be connecting to this Postgres database within the container. Okay, now once these migrations are already run, we should be able to see all those tables here. Yeah, so you see bookmarks table is there, flyway schema history table is there, and sequence is there, right? So this way it is more convenient now. If you want to debug anything, you can simply put a breakpoint and then you can debug it, right? So this is the reason I like to split, so that if I want to run the entire application in Docker, I can use run.sh start. It is going to start all the dependent container and the application, and I can use it. But if I want to, during the development, I want to spin up all the dependent services in Docker, but run the application in IDE, I can do start infra and then start the application in local profile. And one more thing, if you are not using IntelliJ Ultimate Edition, maybe you can pass that environment variable here. As IntelliJ changes their UI, maybe you need to pick up this environment variables here. As of recording this, it might change in future, but basically you can pass environment variables that says spring hyphen underscore profiles underscore active equals to local. Okay, I'm removing this from here. So this way also you can enable a local profile, and this option is available in even community edition as well. Okay, let me restart. So here you can see local. So even if you are using community edition, you can enable profile like this. Okay, so how convenient it is. Like now just imagine somebody just cloned the repository, and what they can do, yeah, make it, let's add those commands in our readme file. Okay, so this is the thing I would like to do for every project. Like once you clone the project, there should be instructions in readme how to start the application. Okay, nice. So that anybody who is joining this project will be able to easily up and run with these simple commands, so that they don't have to remember all those long Docker Compose commands. Cool. So for now, we have configured only the services or depending services like Postgres and then backend API only. Once we build the front end also, we are going to add one more container for the UI as well. And also we are going to update run.sh file if required. Okay. I think we are good with the backend API. I hope most of the things are all ready. If there is anything missing, we'll add along the way. Okay, in the next episode, we are going to start building the front-end UI using Next.js. Stay tuned for the upcoming videos. Bye-bye.